Right, good morning, everybody. A very, very warm welcome again to all of you. This week around, a really, really special webinar we've got on. I think this is my first ever RHS Chelsea webinar that I've done, my short history of doing webinars. And there's a few faces that you'll recognise speaking today. Richard Bowman, who's done a number of these webinars, will be talking you through the Biophilic Classroom. And the reason this is special is, as you will have seen from the various posts and stuff that we've done, Richard and his wife Clare Bowman have done a huge amount of work in the kind of the biophilic arena and thinking around that. And Clare is live at RHS Chelsea, having very, very successfully won a gold medal for their stand there, and particularly around the work that they did for Putney High School. And it's on that basis that Richard's going to be talking about introducing biophilia, but also talking to you about the project, and Claire will be showing you a bit of the stand, and we'll do a bit of Q&A at the end. But before we kind of get into that, just by way of a bit of admin, the usual kind of stuff really, if you can keep your mics on mute. If you save your questions or have questions in the middle of the presentation, if you use the chat box, we'll try and get through as many of those as we can do. And as I say, we'll do a Q&A session at the end. So depending on the amount of people on there, we might be able to go through those and answer those. And as you guys will also be well aware, increasingly we're doing more and more webinars through MESHWORK, trying to share the knowledge that we've got together. Do share the platform and what it's about with colleagues. And again, we've got a lot of exciting stuff coming up over the next few months and well into next year. It remains entirely free for people on it. So as I say, do spread the word. Next slide, Rich. And just a quick 30 seconds on Mesh Energy. Again, if you're new to these webinars, we're an independent and holistic energy consultancy practice. Really, we are striving to work with design teams and those involved in the sustainable built environment to, just to share our experience and help those low energy projects be more successful. As a business, we can help at any of the REBA stages. The earlier we get involved, often the bigger impact we can make. And we're based in the south of the UK, but really not geographically bound whatsoever by the projects that we're doing. So that's enough about Mesh. Let's get on to what we're talking about today. As I say, Richard is going to be heading up the first kind of half an hour of the talk. Then we'll I think we're going to hand over to Claire. She's going to show us the stand at RHS Chelsea, and then we'll do a bit of a Q&A and wrap it up after there. As I say, no later than 11 o'clock. So let's kick it off. Richard, over to you to get into biophilic design.
Thanks, Doug. Good morning, everybody. Let me just quickly rearrange the screen. Today's subject is all about a project called the Biophilic Classroom, and what I'm aiming to do is take you on the journey that Claire and I have been on with GDSC Putney High School for girls on getting to where we are today. So today, a vast majority of working environments are located within urbanised areas. And so we have to deal with disruptive factors, including noise pollution and ever-increasing population, ubiquity of technology and transport. And research has shown that this type of chaotic environment can have a negative impact on our stress and energy levels, and this results in mental fatigue. And so I'm going to take you on a 3.5-year journey in 30 minutes. So really, a brief history, biophilic design. So biophilia is simply a love of nature. And given the evolution of humanity and our adaptive response to the natural world, we have this tendency and subconscious inclination to seek connections with nature. The biophilic concept is an approach in architecture and design that really aims to increase the connection of building occupants to the natural environment. So through highly sustainable elements like natural lighting, ventilation, natural landscapes, and the poetics of space, any building that can serve as a bridge that allows people to connect with nature while indoors. And we see this in standards such as the WELL standard, which addresses air, water, light, comfort and mind in its approach to buildings in use. But I won't be discussing the WELL standard today. Greener environments have been shown to increase frequent physical exercise up to threefold, as well as being linked to a reduction in early childhood asthma. Exeter University has reported reduced mental stress and increased degrees of life satisfaction. At the same time, green views from a workspace have shown a 23% reduction in absence through illness. And this supports Kaplan and Kaplan's attention restoration theory, which was developed really through the psychology profession. So there are fundamentally three parts to biophilic design. The first is really called nature in space. And a space with good visual connection with nature will feel whole and it grabs one's attention, can be stimulating or calming, and it can convey a sense of time, weather, and the patterns of other living things. At the same time, ambient conditions are perceived as complex and variable, but at the same time, familiar and comfortable, whereby sounds and aromas and textures are reminiscent of being outdoors in nature, while we're still indoors. A space with good non-rhythmic sensory stimuli feels as though one is kind of privy to something special, something fresh. It might be interesting, stimulating, energizing, and it can be a brief but welcome distraction in a space. A space with good thermal and airflow variability feels refreshing and active, feels alive and invigorating and comfortable, but it provides a feeling of both flexibility and a sense of control. And then I think one we're probably all relate to quite easily is a presence of water, which can feel compelling and captivating. And so that fluidity and the sound, lighting and proximity and its accessibility to water contribute to whether a space is stimulating, calming or both. And then of course we've got dynamic and diffuse lighting conditions that help convey an expression of time and movement and can invoke feelings of drama and intrigue and buffered with a sense of calm. And this connection with natural systems is the awareness of natural processes, especially seasonal and temporal changes that take place in a healthy, active ecosystem. Natural analogues include biomorphic forms and patterns that are symbolic references. So these can be, for example, wall surfaces that are contoured or patterned or textures using numerical arrangements that persist in nature, such as the Fibonacci sequence or Islamic or Japanese geometry. And this creates, the materials that are used can create a material connection with nature. So, if the materials that are used to make the elements in the space come from the surrounding nature through minimal processing, they start to reflect the local ecology or geology and bring that that distinct sense of space to a place. Complexity and order is really the rich sensory information that we're not sort of really consciously aware of all the time. But it helps us understand the spatial hierarchy, similar to those encountered in nature. And I'm sure we're all aware of fractals, and that's a great sort of illustration of this particular element of biophilic design. The third sort of fundamental area is the nature of the space. And this is to do with the deep psychological connection to nature of the space. And a good example of this is the African savanna. And this has been studied quite a lot because it gives that sense of prospect. But also you can see in the foreground of this picture, there's a place of refuge. But also in that sort of foreground to the horizon, there's a sense of mystery. We don't quite know what's there. There could be risk or peril. And these all invigorate space. And so this is a very brief overview, but if you're interested in reading up a little bit more on it, if you do a search online for the 14 patterns of biophilic design, this is an online document done by Terrapin Bright Green, and it goes into great detail to do with biophilic design and really gets into the nuts and bolts of it all. The second area I'd like to touch on is the Flourish Model. And we're fortunate to have Professor Derek Clements-Croom with us this morning. And he developed the Flourish theory that really promotes creating a natural and harmonious environment, which will stimulate the alpha brain waves, which are connected to high relaxation, and also to lower the high beta brain waves, which are associated with high stress. And so the aim of the Flourish model is to calm the mind, to improve attention and create the space for imagination to thrive. And so when you look at it in detail, it's very complementary to both architectural design and biophilia. It's broken down into subjective parameters that we can relate to design. There are objective parameters that we can assess through building performance data. And this is something that at MESH we do typically at REBA stage 2 and 3 with dynamic thermal modelling and stakeholder engagement. And also it's something you can do at post-occupancy evaluation stage at REBA stage 7. The third quarter will be of interest to owners and occupiers alike at REBA stage 1 and 7. And BRE's own research into the value of sustainable building performance and design supports this. So we're looking at the value that is being brought to productivity and performance, the economic value of a sustainable building, and so on and so forth. And then the fourth quarter is really perceptual. And this, I think, is the quarter that really relates to the work that we've been doing and biophilic design. So it supports improved health and well-being that can be measured. And so the Flourish model is really considering the whole life of a building in a very holistic manner. So now we get into the journey that we've been on, I think. So around 2017, I was an independent sustainability consultant to the BREEAM Excellent project at GDST Putney High School for Girls. And this project is really to deliver a new 3 sciences and music faculty on the campus. The project is delivering this, and it's in progress at the moment. It was designed by Claire, who now heads up RCZM. And also on the call, we've got Susie Longstaff, who is the head mistress of the school. So we'll be chatting to her a little bit later. And around 2017, CIBSE and UK CIP held the 3rd Green Infrastructure Design Challenge. And this is a competition that asks for designs and buildings, existing or in planning, that demonstrate how both indoor and outdoor green infrastructure can contribute to the health and well-being of occupants, while simultaneously improving the building's energy efficiency and climatic resilience. And so GDST were very kind enough to approve an anonymised entry to the competition as the project was pre-planning. And so we submitted a proposal entitled A Living Lab for Bright Minds. And this was presented at EcoBuild 2018. So really to get inside this project, the World Health Organization have recognised the challenges of urban environments for a number of years. And it's worth bearing in mind that around about 40% of under 16s walk to school in London, while about half of under 10s walk to school. And we are, in recent years, we've become more and more aware of how urban particulate air pollution is a serious health issue. And thankfully, trees within cities can remove fine particles from the atmosphere and consequently improve air quality and human health. And biodiversity is a great indicator of the ideology of a location. And this particular school campus has 32 different species of trees that may support over 300 insect types. There's at least 7 mammal varieties and 15 bird species. So it's incredibly diverse at the moment. And the modest tree cover has the potential to drastically reduce the urban heat island effect. Certainly we're aware of this in cities. And because green infrastructure is providing evapotranspiration and shading. The school, and if we place green infrastructure directly in front of south-facing walls, for example, they can significantly cool a building and reduce the cost of air conditioning and cooling energy bills, as well as attenuating rainwater runoff for improved flood resilience. And they form acoustic barriers, so we're reducing city noise levels that are reaching the openable windows of a building. But what we do know, but we can't unfortunately simulate this, is that deciduous tree belts will typically provide about 80% shade in the summer, and at the same time allow pass-through of 80% of daylight in the winter. So we're getting that natural shade and that sort of wintertime admittance of solar thermal gain when we really need it. The indoor air pollutants that can affect health can contribute to sick building syndrome. And this causes symptoms ranging from allergies to headaches and fatigue to more serious illnesses in more concentrated environments. And the WHO estimated that poor quality led to several million deaths in 2012, while Yale University's Environmental Performance Index has calculated over 1.8 billion people have inhaled polluted air over the past decade. But the good news is that green infrastructure is known to reduce local particulate matter by 10 to 20%. So we know that green infrastructure is doing more than making our urban environments more picturesque. To give you an overview of the school, it's got a very strong collaborative culture between the students. They're very spirited and vibrant. They're inquisitive and very intellectually curious and certainly love learning. The school really acts with integrity and kindness and a sense of moral purpose as a very collaborative and democratic community. They're innovative, they're genuinely open to ideas and ambitious and very bold, but also very down to earth, and they're encouraged to speak up. And so the students form part of almost a 20,000 strong organisation with over 76,000 alumni living in over 100 countries around the world. And these include Oscar-winning designers, authors, cutting-edge scientists, campaigners, broadcasters, engineers, entrepreneurs, professors, and Olympians and distinguished lawyers. So they have a fantastic learning environment. And what we did was, with this Living Lab for Bright Minds, is presented 4 design responses to the CIBSE brief. It's estimated that about 20 to 25% of the building envelope for 20 to 25% of city buildings would increase greening by 30% with the introduction of green infrastructure. And this would really bring significant benefits to the microclimate, in addition to visual amenity. Green infrastructure provides shade for the urban heat island effect reduction and UV protection. And green roofs have been shown to be about 50% cooler than your typical hard roof, really. Neighbourhood trees, interestingly, increase surface roughness of the urban morphology. And so this has the potential to reduce wind speed by half. It will reduce surface water runoff by about 2% for every 5% increase in tree cover. So, and a pilot study on a hot summer's day in Manchester city centre found that surface temperatures on a paved public open space were reduced by about 13 degrees under a mature canopy of trees compared to full sunlight. Planted windbreaks, for example, have been found to reduce annual heating costs by about 10 to 30%. And of course, this leads to carbon and energy savings in the operations of buildings. Roof level green infrastructure improves rainwater attenuation. And what this means is about anywhere between 60 and 90% of rainfall may be retained, with the runoff rate reduced by 65%, and will actually delay runoff for about 3 hours. So you're really taking the pressure off the civil drainage system and reducing localised flash flow. Research has shown that PM10 is successfully filtered through leaves, with precipitation on leaves reducing resuspension, and may reduce volatile particles in the atmosphere by about 60%, depending on the species. The Biotape area factor was a reference point for me on the competition. And this was developed by the city of Berlin, and it's to assist in reducing environmental pollution in the inner city area, which is why Berlin is commonly known as probably the most greenest city in the world, although Singapore is obviously trying to catch up very fast. And really the purpose of the BAF is to focus on improving the functionality of the natural balance and promoting biotope development while maintaining current land use. And the way the biotope area factor works is that depending on the type of surface area in a development, then there's a factor applied to that, and you can develop a score for the degree of infrastructure, green infrastructure. So, for example, a sealed surface impermeable to air and water that has no plant growth has a weighting factor of 0 per metre squared. But say a surface with vegetation that has no connection to the ground, but has about 20 to 40 centimetres of soil cover, has a factor of about 0.5 per metre squared. And then you have green roofs that have a substrate of, say, more than 50 centimetres combined with artificial irrigation will have a weighting factor of 0.8 metres per metre squared. So what this meant was we were able to do a measure of the existing green infrastructure and benchmark that at 0.27. And then through different interventions, we could actually raise that to 0.4. But then we're looking at the school master plan, and by doing simple things like changing vehicle access, parking, and multi-use games areas to a partially sealed surface that was permeable to water, and introducing some retrofit wildflower roofs and external vertical greenery, we could get this factor from 0.4 to 0.53. And it's worth bearing in mind that the new London Plan 2021 now includes a very similar approach in its green infrastructure section. So I would encourage you to have a read of that part of the London Plan. And so Design in Response 2, as part of the project, was really to do with biophilia in education. And what we wanted to do is provide an opportunity to enhance the education environment through long-term applied learning, enhance creativity and decrease stress, improve comfort and health and well-being whilst learning, and also support energy efficiency and the climatic response of the education facilities. So looking at sort of small ideas such as the introduction of a tree-level walkway that was proposed for access to wildlife, camera traps, feeding stations, and so on for habitat studies. And this would have been planted willow around a hardwood framework and provide an enclosed willow treehouse classroom that just would add just a sparkle to the environment. But also it meant that the education environment would then become, any education environment really becomes transformed into one rich in things to see and explore and think about, and provide a deeper level of knowing, as well as improve levels of productivity and creativity, raise cognitive performance, improve memory recognition, but also bring in that mystery and enchantment to education as an experience of being sort of caught up and carried away. Design Response 3, and this really came about through a lot of reading that I was doing at the time, and it was very interesting to learn, for those of on the call old enough to remember, that while monitoring the environment of Skylab back in the 1970s, which was kind of the predecessor to the International Space Station, NASA detected a presence of over 300 VOCs. And this would be a problem to the health and well-being of astronauts on long-term flights in space. What they did find in response was that houseplants purified air in sealed test chambers. And so 50 plants have since been documented for effectiveness. And this is for formaldehyde removal rates, emission of water vapor, suppression of microbes, and also balancing out the relative humidity with as long as you've got the required lighting conditions. And so in summary, if we remove the formaldehyde, then the rest of the VOCs will follow. And so I drew inspiration from NASA, as well as the UK Space Agency's microecological life support system alternative, called Melissa, And this is a European project for a closed life support system for manned space missions, where otherwise this support would result in a tremendous cost of bringing everything along that we needed for the journey. So it would be, if you're aware of terrariums, then it's almost saying that with the spacecraft, we're going to treat it as a terrarium. So people occupying the space alongside the green infrastructure. This green infrastructure would help purify the air, it would deal with the waste, it would balance the humidity, it's going to process the CO2 and emit oxygen and so on and so forth. So we could suddenly see the role that plants had to play was way beyond being decorative. And so I established the urban context in terms of particulate matter and tranquility. And the Living Lab will provide a source of inspiration and act as a catalyst for future products through student horticultural ownership of food production and individual plants. And the Living Lab for Bright Minds was designed to actively demonstrate the importance of green infrastructure, and referring to the UK Space Agency and NASA. And so it could become an integral part to teaching the 3 sciences curriculum in a manner that is engaging, informative, and also visually amenable. And the thing about the 3 sciences curriculum is in each of the sciences, it covers cells and organisation, nutrition and digestion, gas exchange systems, health, photosynthesis, cellular respiration, relationships and ecosystems, genetics, stem cells, evolution, energetics, materials, earth and atmosphere, energy transfer. There's all these bits that are related to changes in systems and space physics. And so green infrastructure has a part to play in all these in some shape or form. And each student would be able to own their plant effectively from seed to nurture and study its growth, and be able to study the physiology of their plants, as well as contribute to the school environment in parallel with the changing complexity and development of their own education. And so this led to a research proposal, because indoor environments with natural elements such as green infrastructure and daylight have been found to be 15% higher level of well-being, a 6% higher level of productivity, and as well as a 15% increase in creativity compared with those spaces with, that people will occupy with no natural connection. And similarly, the Identity Realisation Research Group at Exeter University found a 47% higher sense of well-being and almost a 40% higher level of productivity, which was backed by a 45% higher level of creativity. And so what happened was the Living Lab for Bright Minds morphed into the Biophilic Classroom. And the scope basically included 3 classrooms, one of which was the control classroom. And we felt it, on this point, Claire joined me in the project, and we felt it was important to understand both the objective and subjective outcomes of the study. Because VOCs are basically found in plastics, resins, synthetic fibres, dyes, detergents, petrol stations, exhausts, paints, furniture wax, and so on. And the long-term exposure to some of these these chemicals contribute to what is effectively sick building syndrome, and you can feel sort of fuzzy or disorientated, sleepy, and irritable. And so we felt it was important to look at ways to address this issue through green infrastructure. Just go back one. So the first classroom was the maths classroom, and this was used for nature in the space. So 19 plants were chosen for their air cleaning abilities, and these were put in place. And then at the same time, in the English classroom, we introduced a natural analogue in the form of a wall mural. And what was interesting about this is the wall that the teacher faces. And then in turn, facing them was a horseshoe of student desks. And so everybody really has a different view of the classroom depending on where they sit. To put this into context, the WHO guidance is such now that there are parts per million exposure limits for VOCs for short periods of time. And so the role of the plants really is to remove chemical vapors, to be easily maintained and grown, be resistant to insect infestation. It could become annoying. Transpiration rates, and that's the plants exhaling water to increase humidity, and to provide engagement with the curriculum, and also to help create calmer environments. But the reason we also collected data on internal and external particulate matter levels and the air quality index, as well as long-term CO2 levels, is that they're good indicators of changes in quality of air relating to VOCs. And these requirements are quite basic, and they're easy to understand and uphold, so that people living or occupying spaces can have good air quality around them to support health and well-being. And what we did was, it was also very important to understand how the occupants felt about the spaces before and after the biophilic intervention. And so we drew on existing survey methodologies, such as the bus methodology, to design what was a 2-page look-at scale questionnaire to be completed anonymously by the students. And these included subjective responses on the quality of the space, as well as their current cognitive and emotional well-being. And then during the actual study period, the sort of 6 to 9 month period, we used an observational study developed by Dr. Farrell Levers, which studies classrooms in use. And this is to record indicators of well-being and involvement in students and pupils when in class. And that observational study looks at its recording discomfort, whether students are ill at ease or neutral, or there's signs of satisfaction and enjoyment in their environment and what they're doing. And what we found was, in the 3 months before and after the Easter break, room temperatures were stabilised in the maths classroom with the plants. We concluded that there was less window opening occurring in the maths classroom, as it was highly probable that the plants are increasingly contributing to regulating the indoor air quality. So there wasn't window opening to mitigate a sense of stuffiness and letting fresh air in. And on a subjective note, occupants liked having the plants in the maths classroom, and there was a general sense of improved air quality without feeling overcrowded by the presence of the plants. With regard to relative humidity, in the 3 months before and after the Easter break, we found 10% improvement in the maths classroom. And it was observed that there were less water bottles on desks for hydration, whereas the classroom, the control classroom and the English classroom with the mural, the water bottles were still on the desk. However, we did find higher levels of cognitive and emotional well-being and creativity in the English classroom with the mural. And there was a distinct lowering of CO2 levels in the maths classroom. And curiously enough, the maths students found themselves to be more focused, while the English students found themselves to be more creative and expressive. And this was noted by the teachers. Maths students had high levels of involvement and engagement in learning with no visible signs of stress. And they considered themselves far more focused and motivated and alert. And really the level of engagement and involvement went from already being high to extremely high over the course of the study. So in summary, from the Biophilic Classroom study, we found that there was a positive outcome. I mean, we knew that nature in the space and the analogues were having positive impacts, but in different ways. We confirmed that really NASA's findings, although that was in a closed lab condition, the plants were becoming effective in moderating CO2 levels. And also, at the same time, further studies have been done where large volumes of plants have been installed in buildings and had a positive outcome at the same time. So it was really confirming our own research. And so we published our findings of the 9-month wellbeing study at the school. It uses 19 plants. And throughout the study, we had fixed air quality sensors consistently recorded a clear 10% improvement in air quality and a 7% improvement in relative humidity. So relative humidity was basically oscillating between 40 and 60%. And this is essential in learning environments to support well-being. So what happened next? Well, really, this is where Claire became far more involved with me, really. The research is available on ResearchGate. It's on the GDST website and RCZM website. And this led to the development of a legacy project, which is now known as the Futures Hub at Putney High School. And this was to create a space that created different types of learning and meeting environment in a space that already had a good visual connection to green infrastructure outside the space as well. And it was highly collaborative. I mean, we involved lots of different manufacturers and suppliers from around the UK in order to create this. And so here you can see some photos of how the Future Hub now looks when it's at the school. The use of plants is now spreading throughout the schools, so getting more requests. So the original 19 plants has now grown to about 300 in total. Some of those plants have actually been propagated from those original 19 plants. So the growth is natural growth and expansion. And it's becoming ever increasingly popular. So we're finding that form tutor groups are meeting in the space. There's staff office meetings happening there. Students are studying there, either individually or in small groups. And so it's having a really wonderful positive outcome. And this initiative was picked up by the Times newspaper and the BBC. And also the Royal Horticultural Society picked up on the project as well. And so we were invited to display this legacy project in the Discovery Zone of the Great Pavilion at RHS Chelsea in 2020. Unfortunately, the show was cancelled, but we were invited to display this year. So what would have been a post-show legacy project became the legacy project. And then a week ago, the foundations were laid. I mean, this is a view of the base of the stand in the Grand Pavilion. And this is what this is a close-up shot of what it looks like today, because then people like Interface Carpets came in and 16.3 relocated the structure for us. And then all the plants and murals and the 2020 Year 11 GCS artwork was installed last Thursday. And the artwork was really important because this was partially the students' response over the last year to the biophilic design in the school. And so it provides a great abstract visual connection between the creativity and the biophilic design. And then this was followed by 3 days of perfecting the stand. And over the last 48 hours, we've been discussing our work with botanists and policymakers, movers and shakers, as well as the media. And then yesterday morning, we went down to the stand. And the RHS awarded the entire team for their belief in making this positive change with the 3 years of effort to provide really objective and subjective evidence to support biophilic design in education. I'm now going to hand back to Doug, as we've got Susie Longstaff, the headmistress of GDST Putney, with us. I've got Claire from RCZM, she's on stand. As well as Professor Derek Clements-Croom, the author of the Flourish Model, for Q&A.
Thanks, Rich. If you just want to stop sharing your screen, that would be great. You know, I've heard Richard and Claire talk about this lots of times. Obviously, you know, Richard worked for us. I'm still gobsmacked by you know, the effort and the research that's kind of gone into this. And as I say, Claire is there right now, and we'll try and get her on there. We'll get you to unmute Claire and spotlight you and have a bit of a around.
Okay. I'm going to try and walk you around. So first of all, I'm just going to pop you here so that we can show you what we found yesterday morning. And I'll get Susie to speak a little bit in a minute. It is incredibly busy here. And I don't know if you can see. So this is the stand. as it is, and it really is. We're calling it Putney on Tour because this is the school relocated, but I think the artwork that you can see by the students is incredible, and it's really nice to be able to showcase their Year 11 artwork that didn't get to have a show. This is where we are in the Great Pavilion, and I'll just do a little bit just to show you, but I have to say it's very, very busy here, and we've been very busy with teachers, and as Richard said, all kinds of people, but I would say particularly what we've been giving away. If I just grab one, apologies. On the stand, we're giving away, sorry. We're actually giving away a poster for schools, and this is actually online at the on the school website, but it's a poster to help all schools add plants, and also it gives the equation of how many plants that you need in a school. Okay, so I'm bringing this close because it's slightly busy in here.
So this is, so Claire, does that leaflet that you've just showed us, has that got these 19 plants, on that you shortlisted?
Yeah, well, we've actually gone to a top 10 because now we're bringing us in. If I hold it in, what we've got here is a top 10 of plants that survive in a school if they're watered every 2 weeks, or maybe forgotten. You know, you need a little bit of grace with the plants that go in a school, but they really do make a difference, and I think it was the value. So many of them have babies, so we've now got quite a collection of babies in the junior school, which we now call Born in Putney.
Yeah.
But what you actually need is 1 plant per 6 cubic meters, so it's not that many plants that you require to make a difference. And yeah, but again, if you're not coming to the show, this is downloadable from the school website right now.
Yeah, I mean, it would be great to be able to share that. And we all love a finite number if it's possible to do that. It sounds like you guys have managed to boil that down. I mean, what is incredible for me is, you know, we're talking about a school here, but this could be an office. We're all talking about spaces, and particularly when it comes to health and well-being and productivity. I mean, that is so massively far-reaching. It's great to be able to do something on the school, and it would be fascinating to know, what the. I know you said you've got the head teacher there, and what some of the kids. Yeah. I mean, we're all adults, but it would be great to. I don't know if you've got any specific feedback from the kids.
Well, I would happily pass over to Susie at this point.
Yeah, sure.
I'm literally just typing. We've got 2 minutes because being a school, everything runs to clockwork. And at 10:45, I'm meeting the head girls for our weekly meeting. So, and I can't possibly be late for them. You know, it's like in a school. But can I just say, this has been absolutely, awesome and instrumental, and Claire and Richard as well in the background in support with his work. But Claire has got us a gold medal at CIBSE with her attention to detail, her plan of developing biophilia through the school. And this was really Claire's idea to start the research, but it's got legs, and it's really touched a nerve with everybody. What's particularly important for us at Putney is the time of it. Post-COVID, our students have been sat in fixed seating plans for 18 months. They've been in bubbles for 18 months. They haven't been able to talk to any students in other year groups. Their well-being has been impacted by that. And everything we do at Putney is about their well-being. And this, with the well-being from plants, the cognitive and emotional well-being, they feel better, they're happier. It's bringing the community back together after a very difficult time. Has just been instrumental, and it's, as a community, everybody now wants plants in their classrooms. They're going to have to apply for them because they have to look after them. They have to make sure they fit. It's like caring for a puppy, as we say. They've got to be able to look after them and let them flourish. But it's been great. And what you're seeing is our sixth form centre. This is a classroom in our sixth form centre, which will be taken to Chelsea and is coming back again next week. And the girls say they're really missing it already. But it's great. And the artwork you see is Year 11 GCSE artwork. It all ties in. The research that Claire's done is amazing. And with our wonderful supporters and suppliers, all on the list at the back, as you mentioned, 16.3, for example, an interface. There's many others that please, please do. We'll share the list with you, but they've been fantastic. And Claire must be exhausted because she's been there from dawn to dusk now for nearly 2 weeks.
Thank you.
I've got to go. I've got a meeting.
No, that's fine.
So,
thank you. Thank you.
Thank you, Doug. Thank you, Richard. Thank you, Claire. Lovely to see you all. Bye.
Cheers. Bye, Susie. Yeah, I've just done a quick calculation while Susie was talking there. I'm a few plants down in my office, so I must get out and I'll have a look at that list and figure out what to do next. But I mean, Claire, obviously we heard from Richard there about the journey to getting to Chelsea and the work with the school. I mean, what's been, if it's, before we get into some of the questions, what's your biggest, if you can tell us one or two of your kind of biggest learnings? No doubt you've learned a huge amount over the years that it's taken to get to this point. But if you were talking to other people who were trying to get into this for the first time and trying to push it on, what would you say to them? What's the biggest takeaway from you?
The biggest reason for doing it, and I think we all know and feel this at the moment, is about the fatigue that we actually feel, whether we're in school or anywhere. We have this tiredness from the lockdown. And what we found with the plants is they bring a freshness. And it's the freshness that is so important to our health and well-being. So if you can, even if it's at home or school, wherever you are, add the plants. They give a freshness, which is what we need for our health. The other element is value. That they are value. They do have babies. So if you are thinking of schools, but where we're going now and what we've noticed is it's actually, our new research is more based on SEN and early learning we're doing. But again, creating environments which are much simpler, more natural to calm the mind is going to make, talking about schools because that's our subject, but it's just much better for all of us to have a calmer space. The work we're now, as Richard spoke about the Fibonacci sequence, we're actually creating classrooms which are very white, very natural. So you actually then suddenly see outside, but we've already seen a dramatic change in the children where they're actually independent within 4 days of arriving in school. They're only 4 years old. So, but from our perspective is what we've done at this school is created a design code called the Flourish Design Code. So it's about having simple things you do. And that could be for, you could be a company, a workplace, but it's actually setting a set of simple principles that you believe in, and that becomes your materials, but also, the way you spend your day.
Yeah, I mean, I think you touched on a point there. I mean, I think for those who, maybe struggling to grasp biophilic design or how they kind of get into it, the ability to codify it and simplify it and come up with some kind of methodology is absolutely critical. But I'm particularly fascinated by just the results. I mean, Richard was talking about the increase in productivity, well-being, and creativity, and measuring those, but also the data. I mean, the fact that you can regulate temperatures more effectively within buildings. I think most people would appreciate, hopefully the CO2 levels go down when you've got living plants in an environment. But there seems to be very little, very few disadvantages to this beyond planning it out and maybe pests and watering the things. But that's, it'd be great to see more of this happening.
Yeah, there is. I think it's just with anybody starting. I spoke to a couple yesterday who had never bought a plant ever, and I actually sent them. I sent them off with the guide. Just spend some time together and choose some plants. I said just start with a couple of plants from our guide, and that's what we found with a lot of people, that you start with a couple. And then it's a book, and then you might buy a book, and it's just actually a distraction as well. It just creates a hobby away from our busy lives. But whatever plants you have, they just give back more and more. As I discover, I also have to admit, obviously I work on a computer a lot, but I love coming to the school to care for the plants. And because of lockdown, we've had to have a lot more with us jumping in to help. But I've actually found it to be, for me, a brilliant day out, because within 20 minutes if I had a headache, it's gone. you know, it's just nice to step away from your desk, and as we call it, watering Wednesdays, and just be freshening up the space. And as we've got here, we're actually promoting workshops as well. We've got the botanical boys here who do wellbeing workshops at Cold Drop Yard, building traniums. And again, that's just 2 hours out, spending time either with other people or yourselves, but just allowing yourself to build a terrarium, learn how to care for it. So yeah, basically you can't buy a terrarium, you have to make it yourself. But again, it's a wonderful experience. Yeah, no, that's great. And you know, I do a similar thing. You know, we've got, I mean, my background is the office we've got here in Farnham, and you know, you make yourself a cup of tea, you water a few plants. You know, the plants have obviously different watering regimes, but it's a great way of just, you know, just having a wander around, see what's going on, getting up away from your desk, and you know, having a look around. But Marta's said here, there's a question that Marta's come up with. So she said, a huge congratulations to both of you. You know, it's great to have the results of the research. You know, we've proven prove that there's an improvement having plants around. But she said, you know, again, that the concern is about keeping the plants alive. You know, will we be sharing the list? Yeah, we'll absolutely be sharing the list. So don't worry about that. And I know I value that. Yeah, we will definitely share a list. And honestly, these are really hardcore. Most of them are available anywhere. But just start with a snake plant, but also the eternity plant. That is impossible to destroy. And also cacti. We don't have them on the show because it was just too prickly. But also you can start with succulents and cacti as well, which again, they don't need a lot. But I know that I have to apologise because I haven't even phoned Professor Derek Cleverance since we got the gold. And I believe he might be with us today. And he is, he's on the call, entirely grateful because Derek from day one has mentored us and given us advice, and we made sure we had to follow this scientifically. However, without the Flourish model created by both him and Mary Marilis, we wouldn't be here. But it is the Flourish model that is essential. It's about having something to measure what you're doing, and that applies anywhere, even your home. So yeah, I would like to just share with Derek some of his comments, if that's possible. Yeah, no, that's fine. Just I mean, do chime in. There was just one last bit of Marta's question, which she said head teachers and educating the head teachers and teachers to allow an aim for, you know, what you've done at Putney High School or something akin to that is fantastic. But she's saying, how would you possibly start with a school that was really at ground zero and beyond a few words? So ground zero is start with one room, and it might be the library, and it might be a few puddles of plants in a library or where your children study. But I would literally start with one room, because then you can see what plants like the school, and basically, or a shared space, which is what we've done. So after we did the maths classroom, we then did the library. So we just then focused on shared spaces. We've also then, in the summer, we then did a couple of the offices because the staff were tired. They were all brought back a week early by the government. And so we literally moved the plants into those rooms, and we saw the immediate effect of that. It was smiles everywhere. And then they're caring for them. So and also it is, just start with, if you have a budget of £10, as our friend did, Lisa Cook in Macclesfield. She just went to B&Q and bought all the 50p plants nobody wanted. And now we just heard yesterday she's been given £300, but she started with just 50p plants, but she was given £300 yesterday when we went, because she's followed us all the way through, tried it. So it is just start with a few, really. Yeah, exactly. You know, small steps. You've got the model there. We've now got a great case study of how successful it can be. So there's a few things that can be done there with the head teachers and stuff. Eric, I know you're on the call. I don't know if you're able to unmute yourself and just have a quick chat with us about just very, very briefly about the Flourish model and what you think of the Chelsea result there for Clare and Richard.
Well, thank you, Doug. Well, first of all, I have to say the heartiest congratulations to Clare and to Richard for all this work, and they've been working so hard over the last few years on this project, which I'm aware of, and they deserve a gold medal, and very well deserved. So many congratulations, and I hope they're going to share some champagne or something at the end of the week. And I'm looking forward to being there on Friday afternoon and seeing all the exhibition and so on. Yes, and of course, for myself, I've been very pleased, very honored, in fact, to the fact that Clare and Richard think the Flourish model I've developed over the last few years has found some practical outlet. I've been working on the perception of the environment for many, many years because I felt that just talking about comfort is a very restricted way of viewing how we feel the world around us. We live through our senses, but unless you're in an extreme situation of temperature or light or something, you tend to receive lots of stimuli at the same time. And that diversity is important. That's actually more important than just trying to be very accurate about being at a particular temperature. The human being likes to engage all of the senses in the environment. And it was the great biologist E.O. Wilson in 1984 wrote the book on biophilia. He's still alive, and he's, of course, a biologist, but he'd seen from that world that he had researched for many years the importance of our surroundings, our natural surroundings, the green environment. Now, talking about human beings, I mean, we were, until the Industrial Revolution, usually in green environments, but when we started developing industrialization and cities and so on, we tended to leave that behind. There was, of course, the work on the Garden City in the 1900s by Ebenezer Howard, but now, with great force, we're seeing that human health and well-being is a very fragile thing. And anything we can do in the environment to improve that is important. We talk a lot about temperature, but the quality of the air is just as important. And in some ways, it's quicker to respond to because what you breathe in reaches the brain via the bloodstream in a very short time. Now, the value of green is so many things. It's not just that it looks nice, which is another aspect of perception, which is important. We work better in attractive surroundings, but it's also the smell. You may not always think you're smelling something, but in the air, there are these invisible things which affect the olfactory system, and this impacts the brain. And that's the other thing we're finding from neuroscience, that things we didn't realize affect the brain very, very much so. And if that affects the brain, that affects your thinking. Therefore, the responses of the school children in this particular experiment, in a way I'm not surprised about, but it's nice to see some real evidence by carrying on getting feedback from the users of these classrooms. And they are reporting, as you've heard from Richard, that they feel better in sort of several ways. They feel their concentration is more. This, in fact, ties up with my own work on 8 primary schools around Reading, where we found a similar thing. We weren't actually examining biophilia there. We were just looking at the importance of air quality and the importance of CO2. And as Richard has pointed out again, that the green environment affects the CO2 levels, and the CO2 levels affect your concentration and your cognitive function. So these are making a real contribution to learning, and that's what your children go to school for. They're going for learning, and of course the teachers as well. They're doing their job, and it's better for them as well. So. I don't want to go on too much.
No, that's fine, Derek.
But I'm glad to say the work that I've done is on a holistic basis. And as you heard from Clare and Richard, this is so important. So well done, congratulations.
Thank you. One final, just quick question for you, Derek. You mentioned a book there, which you said was the book about biophilic design. What was that book called again?
Well, it's literally called Biophilia, and the magic is the E.O. Wilson is the author, and it's
E.O. Wilson, Biophilia by E.O. Wilson.
1984. So it's an old book, but it's a classic.
Right. Okay. That's great. Well, thank you very much for your last few kind of comments there, Derek. We've come to the time where we've got to wrap it up. Once again, this is a massive subject, but great to have some time spent on the work that's been done on Putney High School for students. As you can probably appreciate, a huge amount more work to do in other schools and other environments where productivity and creativity and well-being are important. But for now, again, a huge thanks to Richard, to Claire, to Susie, to Derek for their input. We will be recording this. This will be up on YouTube. So if you've had to duck out or you want to share this with somebody else. In fact, having said that, we're not going to put it on YouTube. We're going to put it on MESHWORK. So join MESHWORK and get anybody who wants to watch this back onto MESHWORK. We'll do no doubt more of these biophilic design webinars, as well as a huge amount more else. Next week up, we're doing, Richard's going to be talking about thermal standards and overheating to wrap up our, some more stuff on health and well-being for the month of September. So once again, thank you, folks. Thanks for your time, and we will see you again shortly. Take care. Thank you. Cheers. Bye-bye.